we get Beka. Beka is in the room, gets to come up here and talk.
And then there's a break.
And we will have a break after Beka. You get the...
Yeah. Hello? Wonderful. Okay. So, over the past few months, I've developed something of a new obsession, which is making Blockly run fast. I believe that as a library maintainer, it is my responsibility to remove barriers to coding that affect all downstream users of Blockly. And one of the biggest barriers is performance. Performance is vital to your end user's experience. Dealing with lag is frustrating to your users. It takes up their mental space, and that mental space is necessary for them to code. If your interface is slow and unresponsive, your users will give up on programming and quit. So, today we're going to talk about how Blockly has measured performance and how it has improved it through render management and drag optimizations. Improving performance was approached by measuring common user interactions, like deleting blocks, inserting blocks, and collapsing them. Measuring user interactions is the perfect Goldilocks approach to performance improvement because it allows us to look at small enough chunks that we can analyze the data, but large enough chunks that changes we make are actually impactful to users. These interactions were measured using Chrome's performance profiling tools. These were incredibly useful because they allow us to see the entire length of an interaction, as well as the time spent in layout code versus script code, and which functions were taking the most time out of an interaction. So using these, we identified two major performance sinks in Blockly's code. The first being render management. The render management system tells the renderer when to figure out the shape of the block. This includes when fields are edited, when inputs are added to a block, when blocks are connected together, etc. It happens all the time. And in the old render management system, we were being incredibly inefficient. The render management system created lots of calls to the renderer that were never actually drawn to the screen. For example, when inserting one block in between two others, we would create 11 different calls to the renderer, 8 of which were never actually seen by your users. These unseen render calls took up a lot of extra time and made the interface unresponsive and frustrating. So in the new render management system, we've added batching. Instead of calling these unseen renders immediately, we queue all of the render calls and then execute them right before the frame is drawn. This allows us to create a tree representing all of the blocks that need to be re-rendered and render each of them exactly once. This has cut our 11 render calls down to just the necessary 3. And the great thing about this is that as a developer using Blockly, you don't need to worry about this system at all. All of the batching happens automatically under the hood, and you don't have to change any of your code. This one refactor has created tons of recognizable improvements, which are already available in version 9 of Blockly. In many cases, it took interactions that could take over a second and cut them down to a fraction of that. Deleting blocks and collapse blocks are both 3 times faster than they were in version 8. And inserting blocks is a whole 5 times faster than it was before. So, render management was our first major win, and drag performance is our second one. Before, dragging a workspace was incredibly laggy. Even just 100 blocks in your workspace could drop the frame rate down to 3 frames per second, which is essentially unusable. This made it difficult to navigate the workspace, difficult for your users to understand their code, and made programming incredibly frustrating for them. It turned out that after some investigation, we found that this performance drop was actually the result of an old optimization that had since become an albatross. So dropping that old optimization gave us a 3 times performance boost, significantly improving the experience of programming for your users. And this change will be available in version 10, coming out at the end of this month. So in summary, performance is absolutely vital to your users. We want to improve performance at the library level, and we've already made significant progress in version 9, with more to come in version 10. So thank you for listening to my talk, and now I'll hand it over for questions.
Thank you, Beka. Any questions in the room about performance? I see one.
What if I want to do some work, like right after Blockly renders something? Can you help me with that?
Yeah, so if you're trying to do something that relies on the shape and position of the block already being calculated, then you need to know when the render management system has triggered that. So we've added a callback that you can, it uses a promise-based system. So you can add another promise to that chain to know when the blocks are completely rendered to then do your work that happens after that.
Thanks, Beka. That's amazing.
Cool. One more looks like in the room from Neil.
Can you talk about the albatross?
Yeah, so what actually happened was that we had an old optimization where when we started dragging a workspace, we would move all of the block SVGs into like a separate SVG group. So then it would be ideally more performant for dragging them at once. But it turned out that that wasn't actually better than translating each one individually, and actually moving all the blocks at the beginning of the drag was a significant slowdown. So removing that movement of the SVGs made it much faster to drag a workspace.
Awesome. I don't see any more questions in the chat, so going once.
I had a question, if I
All
have
right,
a mic on.
take it away.
My question is, what are you going to do next?
What I would like to look into next is there are a few places where the render management system hasn't been threaded all the way through all of the places where we call the renderer. So in particular, like icons are still outstanding, and also deserialization. So when we're loading a workspace, the render management system still needs to be added there. And then additionally, I would also like to look at the performance of deserialization in general, since that is such an important part of the user's experience, is how fast their blocks come back when they look at a project. So I want to make that as snappy as possible.